required. No, not this. You are seeing the PDF. No, we don't want to do this way, at least not now. Yeah, this one. Okay, and so let us again repeat the definition of invariance. What are invariants? Last we had seen in the last class, but છેલ્લે જે લોકો આવતા હતા એ તો ઘટતા ગયા હતા નંબર. In the end, it dropped around 40 or something, 45. Yes, invariants. So what are invariants? So let G be a group of, let G be an abelian group of order p power n. By the above theorem, we know G can be written as, so suppose G is written as, last theorem correct? So what was that? Any abelian group of order p power n can be written as direct product of cyclic groups. So suppose G can be written as A1 cross A2 cross, let us say, of course, when I say I missed here, it should be a finite abelian group. બોર્ડ ઉપર એ પછી આવું કરવાની આદત પડી જશે. It is finite, it is understood. Sorry. Yeah, p power n when I have written here, so it is understood. So suppose G is this, where what are the AIs? So AI equals to AI is cyclic of order p power ni such that n1 greater than equals to n2. This is what we have obtained from the last theorem we had seen. Every group, abelian group of order p power n can be written as product of cyclic groups, and the order kept on decreasing. We started with the largest order p power n1 and so on. And these are all positive integers, which we may or may not mention also, that is fine. Then the integers, n1, n2, and nk are called invariants of G. So what are invariants? These integers, they are called invariants of G, where G is a abelian group of order p power n, and such a sequence of integers we have, they are called invariants of G. So by the definition, what we can say, order of G equals to, what is order of G? This is equals to order of A1 into order of AK, right? Okay. Yeah, so what is this? So this implies on one side we have p power n. On one side we have p power n, and on the other side we have p power n1, and this product p power nk, which is nothing but p power n1 plus up to nk. So what does this give us? This gives us that n equals to the sum n1 plus n2 plus nk, right? So that means invariance gives rise to a partition of n. right? So that means where N1 is greater than equals to this already I have written. ખબર નહીં હું થાય ટાઈમ આવીને બંધ થઈ જાય કામ કરવાનું. Yeah, so that means invariance gives a partition of n. No problem, we'll go slow. Right? Invariance gives a partition of n. Right, but see, invariants are unique, but the cyclic groups may not be unique. So the cyclic groups AI need not be unique. And this we have already seen. Already we have taken an example of Klein for group. For example, G equals to K4. And K4 we had written as H1, H2. Right? We had also written this same as H1, H3. And this is same as H3. We can write H2, H3. Right? Where H1, H2, H3 we know. Where H1 H2, this is EB and H3. Sir, speed કરી જ ના શકે. Sir ની pen કામ કરે તો ચાલે. Yeah, so see, these are not unique. However, the invariants are unique. So what I want to say is, however, however, the invariants, let me switch off and switch in again. However, the invariants are unique. Okay, yeah, let me stop sharing and then switch off my tab. Yeah, so can anybody give me invariants of plane for group? Anybody? What is order of plane for group? 2 square, right? Yes, Vaishali?
1 1.
Yeah.
1 1.
Yes. So the invariants of plane for group are 1 1. So order of G, the same thing is happening. I don't know why. Order of G is 2 square. And this we wrote as direct product of two groups, H1, H2. Both has order 2 raised to 1. So order of H1 is 2 raised to 1. And order of H2, this is also same. So this is also 2 raised to 1. So the invariants of G are invariants of of Klein for group K4 are 1, 1, 1, comma 1. Right? N1 is 1, N2 is 1. Why it is 1, 1? Is it clear? Should I repeat? Should I explain why it is 1, 1, or is it clear? If you want me to explain 1, 1, then raise your hand. No raised hand. So I hope it is clear, right? Because this has order 2 square. This is order 2 square, and the first cyclic group is of order 2 raised to 1. Another cyclic group that is of order 2 raised to 1. So that means, and what are invariants? It does not depend on here. Yeah, it does not depend on prime. Invariance depends on the power of the prime. કયો prime છે depend નથી કરતું. It depends on the power, and then this is nothing but a partition of this. So whatever the powers here we get, those are invariants. Those integers are invariants, right? Okay, yeah. So that means the 2 can be written as 1, 1. So here it is 1, 1. So but invariants of Z4, invariants. So H1 is cyclic, H2 is cyclic. So here there are 2 cyclic groups, but invariants of Z4. What about Z4? Z4 R, we cannot say R, but is in fact, but we can say that invariant is 2, because Z4 itself is cyclic, right? G equals to Z4, and this itself is cyclic. So A1, where A1 is a cyclic group of order 2 square. Here also 2 square, and here also 2 square. So there is only one group. There is no need of any other A2 here. So there is only one group, and so the invariance of this is nothing but n equals to n1. So here n equals to, you can say that n equals to n1. Right? So there are 2 groups of order 4. One has invariance 2. 2 આવી જાય તો એનો મતલબ cyclic થઈ જાય, because the power is 4. So the order is 4. So the power is 2. And the invariant is 2. That means there is only one integer, n equals to n1. There is no n2. And if again the order is 4, so the power is 2 square. But if there are 1, 1 invariants, that means there are 2 groups of order 2 raised to 1, 2 raised to 1, as we have seen here. So this is 2 raised to 1. This is also 2 raised to 1. So that this order, this power is written like this. So there is n1 equals to 1, n2 is also equals to 1. So in this case, we have two invariants, 2 integers as invariants. N1 equals to 1, and n2 also equals to 1. Okay, so this is definition of invariance, and now the most important result is the groups are not unique. So this we have seen that H1 can be replaced by this. Also, the generators may not be unique. Yes, also the generators may not be unique. Generators of cyclic groups need not be unique. Yeah, that means this AI, so that is AI is generated by AI here, let us say, but there may be any more than one generator of that group. So it can be generated by some, let us say, some AI dash. That is also possible. Yeah. So the generator, આની બદલે બીજો generator હોઈ શકે. So here in the example, we have only one generator here, so we cannot discuss this example because the generator of this is A only. The generator of this is B only. The generator of this is C only. But if we have a large, this is only cyclic group of order 2. If we have large subgroups, then it is possible that the generators may be different. You can write any generator, but in invariants are unique. So invariants are unique. The order of this cyclic groups here they will same 2 2. Here also this is 2 2. Here also this is 2. That is not going to change. So that result we are going to prove is two groups of abelian groups of order p power n are isomorphic if and only if they have the same invariant. So two abelian groups હમણાં તો બરાબર ચાલતું હતું. I took a lecture of problem solving for 1.5 hours. There was no problem. I don't know. And a group theory માં જ વાંધો આવે. Two abelian groups of order, yeah, ચાલ મારે ભાઈ. E power n are isomorphic if and only if they have the same invariants. I don't know whether it has to do something with teams or something with screen sharing. Yeah. So if you, this is the second last result. Last result is very trivial. This is the second last result of our syllabus. And one part we'll discuss right now. Let us write the statement again in a different form. Maybe let me try to close this software and try again. Otherwise, I will show you from PDF because the results are easy. કાલ જેવો result નથી. This is this part, at least first part is very easy that we discuss. Let us hope it works now. It looks kind of same. Yes, this is our important result that two groups of order p power n are isomorphic if and only they have same invariants, two abelian groups. So in other words, we can write like this. In other words, let G and G dash speed over these be two abelian groups of order. Okay, now I realize at the end of the course that you have to close the application again and start again. Of order p power n, where p is prime with invariants. If you have any kind of question, anything to ask, anything to repeat, just please raise your hand at any time. So G has suppose invariants n1, n2, and k. Let us write like, let me see how this is written here. And let us write h1, h2, hs or some s respectively.
हेलो सर.
Yes, બોલો.
સર સ્ક્રીન જ નથી દેખાતી.
સ્ક્રીન નથી દેખાતી? મને તો દેખાય છે.
દેખાય છે સર.
દેખાય છે સર. હા.
જોજો એક કામ કરો, તમે છે ને ક્યાંક બીજે પિન કરી દીધું હશે, ટચ કરી દીધું હશે. વોટ યુ કેન ડુ ઇઝ પેલામાં સર્ચ કરો લિસ્ટમાં, ક્યાંક મારું નામ આવશે એમાં પિન કરજો. અધરવાઇઝ સ્ટોપ શેરિંગ કરીને પાછું શેર કરું, પણ તો ખબર નહીં તમને દેખાશે કે નહીં. તમારા ભૂલથી ક્યાંક બીજા ઉપર ક્લિક થઈ ગયું હશે તો કોકનું પેલું પિન થઈ ગયું હશે તો સ્ક્રીન નહીં દેખાય. ઓર ટ્રાય ટુ disconnect and join again. Try to leave the meeting and come again, right? So suppose we have 2 abelian groups with invariants this. So that is, this is I am writing the statement of the theorem itself, right? No proof right now, but suppose this is given, then the proof starts from here. If this is given, then the proof starts from here. You have to name the two groups. Suppose G and G dash are two groups, abelian groups, order p raised to n. You have to name the invariants. Same invariants are given if and only if they have same invariants. So you have to name invariants also. So suppose n1, n2, nk are invariants of G, and h1, h2, hs they are invariants of G dash. So that is this means what? This means G equals to, we can write G equals to A1 cross A2 cross the invariants are K. So there will be K cyclic groups where AI equals to AI is cyclic groups, is cyclic group for of order p raised to ni, p raised to ni, where I equals to 1 to up to k, and we have this relation n1 greater than equals to n2 greater than equals to up to nk, right? This is the meaning of what do we mean by invariants of G. These are invariants of G. So what is the meaning? Because they are k in number, and therefore G can be written as product of this k cyclic groups, each of order p raised to ni, where the first one is the highest order p raised to n1, then the second one, and so on. This we have seen last time. So this, each of them are cyclic groups, and and they are like this. And so similarly, so where that is this, and G dash. What about G dash? What are invariants of G dash? So invariants of G dash are this. That means G dash also can be written as a direct product of cyclic groups. Both have same order, right? P power n. So G dash can be written as, let us say, B1 dash cross B2 dash cross. This proof is easy. At least one part of this is very easy. Isomorphism बताऊँ वो easy थी. Just define a map so that it is one homomorphism 1 1 on 2. So how many will be there? Here this is given S. So there will be S, this bi dash, where what is b? Let us write bj dash. What is bj dash? So that is cyclic generated by bj dash is cyclic group of order p raised to કયો order આવશે? Anybody? જલ્દી unmute કરીને tell.
HI.
J.
Yeah, so એમાં આ નહીં આવે, right? So hi આવશે, ni ના આવે. So p raised to hj, let us say, because અહીંયા bj લીધું છે, p raised to hj, j equals to 1 2, there are s in numbers, so s, not only that, and the relation is h1 is the highest one, h2 is then we have hs. So this is the analysis of the statement of theorem. We are given two abelian groups of order p power n, and they are isomorphic if and only if they have the same invariant. So let G and G dash be two groups of order p power n. This is fixed. Prime is fixed, n is fixed. These are the invariants. So n can be written as sum of this also, as we have seen. N can be written as sum of this also. Okay, so there are k number. And now we prove this part converse. What is the converse? We prove this to this. That means if they have the same invariants, we assume that they have same invariants, and then we prove, this is what we prove, that they are isomorphic. Right? So that is the most easy part of the result. So assume that So now our proof starts here. But if this is not given, this statement is not given, then if this statement is given, then start the proof from here. So in other words, then we start from left. We have to start from here, right? So suppose the invariants are same. Suppose the invariants of G and G dash are same. That is, what is the meaning of this? Invariants are same. That means not only they are all equal, the number also is same. First of all, this K must be same as S. So there are K in number, here there are S in number. So that is not only this. So K equals to S, and not only that, we have each of them are same. So Ni equals to Hi for all I equals to 1 to up to K. Just hold on a minute. So not only the numbers are same, but each of these entries are also same, right? N1 equals to H1, N2 equals to H2, and so on. So for all I equals to 1 to K, and now K equals to S, so there is no confusion. Okay, so invariants are same. So now, therefore, what is G? G now, this is A1, A2, AK. G we can write as it is, where AI is a cyclic group generated by AI of order P power Ni, and we have N1 greater than equals to N2 greater than equals to, this is Nk. So the same thing we are repeating. And what is G dash? G dash is B1 dash, B2 dash. So also last one, this one.
BK dash.
Yeah, BS dash nahi aave. It will be BK dash only. BK dash. Are you able to see my screen? Yeah. Okay, BK dash, where each of this BI dash is generated by BI dash, and cyclic of order P is to HI, and H1 is greater than equals to H2, and the numbers are same and of order. હવે તો અહીંયા પણ શું થઈ જશે? HI ના આવે, શું આવશે? N1, Ni, right? So this is also because the orders are same, invariants are same, so that orders are also same. Yeah, so what we have to show? So બતાવવાનું છે? We have to show that they are isomorphic. So when we have to show that two groups are isomorphic, what do? We define a map. We define a map, let us say phi from capital, let us say G to G dash by. How do we define? Once we define this map, then we are done. Then very simple, easy exercise. Only thing is, important thing is to define a map. And how do we define? What is the natural way of defining this map? How will an element of G will look like? કેવું હશે element?
A1, A2 up to AK.
ના એવું ના હોય. જો બરાબર વિચારજો. See, we have written all the details. Yes, A1 આવશે પણ A1 નહીં આવે. જનરેટર જ આવી જશે સીધો. First element will come from capital A1. Second element will come from capital A2. So આનો element હોય તો કેવો હોય? Right, first element is from A1, second is from A2, and A1. What is A1?
A1 raised to N1.
Huh? Bolo, Amit.
A1 raised to N1.
So it is a1 power, let us say, alpha 1. બરાબર, because first element, of course, Prabhat is right કે first element આવશે એ કેમ આવશે a1, પણ a1 હોય એવું જરૂર નથી, small a1 હોય જરૂર નથી. It is in a1, capital A1. So elements of capital A1 is nothing but it is generated by small a1. So that means it's some power of a1. So a1 power alpha 1, and the second element is coming from this a2, which is generated by small a2. So a2 જોવો જરૂરી નથી, any general element is in a2 is of the form some power of a2. So a2 power alpha 2 and ak power alpha k. So this is an element. Is it clear? So this belongs to a1, this belongs to a2, and so on. This belongs to ak, and so this belongs to the product of this, direct product of this. Is it clear? Okay, I have written their cross product in notation out લીધું છે, but here we have taken multiplication. So because they are isomorphic, so we can abuse this notation any number of times we want. Okay. Yeah. So now what should be its image? કોઈ image આપી શકે? Guess કરો. Anybody? Yes, it has to be in this. We know what is this. They are also cyclic, not HI, but still NI only. Yes, Prabhat.
B1 raised to alpha 1, B2 raised to alpha 2, up to BK raised to alpha.
So B1 dash, we have written B1 dash. Dash because they are elements of G dash. Therefore, we are writing it. So B1 dash alpha 1, and then up to BK dash alpha k. Or we can also write like this. Bracket na લખો ને, alpha 1, B2 dash alpha 2, and BK dash alpha k. Right, so map is defined. Done. So what is the exercise now for you? Exercise means let us do here, so no problem. So show that first. What you show? Phi is homomorphism. Just isomorphism બતાવવાનું છે, very easy. So phi is homomorphism. So for homomorphism, what will you take? શું લેશું આપણે? Yes, let G and H belongs to G. The element layer. And what we have to show? We have to show that phi of GH equals to phi of G, phi of H. But if I take G and H in G, then what will be the element? So then G equals to A1 power alpha 1, A2 power alpha 2, and so on. AK power alpha k. Okay, I have taken one element, which is G in G. Now, can you give an H in G? Another form, H. How do I write H? કોઈ H લખાવશે? Any notation which you like.
સર એમાં પાવર ની ઉપર ડેશ કરીને લખી શકીએ ને, કારણ કે પાવર અલગ હશે તો જ લિમિટ અલગ થઈ જશે.
પાવર અલગ હોય તો
એટલે
yes, પ્રદીપ
A1
લખાવશે.
આલ્ફા
હા, yes, પ્રદીપને ચાન્સ આપો. તમે દર વખતે આન્સર આપો. Yes,
Hello,
Pradeep.
sir.
Yeah.
Sir, A1 raised to beta 1, A2 raised to beta 2, up to AK raised to beta k.
A1 dash લેવાનું તો પ્રોબ્લેમ થાય.
ના ના
A1 dash લો તો
ખાલી A1.
એલિમેન્ટ બદલાઈ ગયું, જનરેટર. હા, yes, that is what I wanted. અમિતને ખબર હતી એટલે મેં બીજાને પૂછ્યું. So see, don't do this. Don't take B1 power alpha 1, or don't take B1 power beta 1. The generator should not change. We don't know whether any generator are there or not. The first element is coming from A1. So it is some power of A1. So the power may be different, but A1 will remain fixed. There is no A1 dash. There is no B1. Don't take B1 because we don't know B1 generates A1 or not. So this is a mistake, common mistake which people make. And પછી તો એમ થાય કે I have written everything, 6 out of 6 marks I will get. અને નથી આવતું એનું કારણ આ છે. પછી બધું બતાવી દે, everything homomorphism, everything goes through. But the common mistake is some B1 is introduced here. So that is not, we should not do. So the first element comes from A1, which is generated by small a1. So it is some power of A1. Here we have taken alpha 1. So let us take some other power beta 1. So So once this is done, then it is fine. So that is why I did not ask you to do. So a1 power beta 1, then a2 power beta 2, then ak power beta k. Now what is phi of gh? So this is phi of g is a1 power alpha 1 and ak power alpha k. So this is g and this is h. a1 power beta 1, ak power beta k. Clear? And now what is this product? So don't write phi of this and phi of this. This is wrong. First we have to operate this inside. So product na શું આવશે? Here is a1, here is a1. Can this element jump from here to here? Can I write this? Jo, how can I? Alpha 1 plus beta 1. a2 power alpha 2 plus beta 2. And ak power alpha k plus beta k. Yes or no? And if yes, why yes? Can anybody tell the reason? What is the reason here? Quick biju, Prabhat Sivaj. Somebody who has not answered? Yes. Can you guess? Answer may not be correct also, it's fine. You just try. Nobody raises hand. Okay, Prabhat, bolo, chalo.
ઉપરનું છે એમાં એક કે આલ્ફા કે અને A1 B1 એવી રીતે બંને ચેન્જ થતા જશે એટલે ડાયરેક્ટ જમ્પ નહીં થાય બધાય નહીં થઈ જાય પણ એક એક એલિમેન્ટ આપણે લઈએ ને એવી રીતે આગળ રિઝલ્ટ આવ્યું હતું ને એવી રીતે
કયું રિઝલ્ટ?
A1 ડાયરેક્ટ પ્રોડક્ટ ઓલા ઇન્ટરનલ પ્રોડક્ટમાં A1 A2 હોય તો એના એલિમેન્ટ છે ને
NIN જે હોય તો આમાં A હોય ને આમાં B હોય. So AB equals to BA. Same thing? Yeah, I also thought the same, and that is correct answer. In my notes also I have written the same thing. But yesterday when I was reading this result, I realized that we don't need to use that. What we are given is very powerful thing. What we are given? So
direct.
So yes, you can replace that. My notes માં લખી દીધું છે, but you can replace that. G is ability. What Prabhat has said, Prabhat જે કીધું ને, same thing I had also written in my notes that this is in capital A1. They are normal. The second one is in A2, so they commute. So we can arrange like this together. But G is abelian. So this is A1 power this alpha 1 plus beta 1 and all. They commute. So no problem. And now what is phi? Phi is what? B1 dash power alpha 1. So here we have B1 dash power alpha 1 plus beta 1. Then B2 dash power alpha 2 plus beta 2. This is how it is defined. And BK dash power alpha k plus beta k. And then separate these two people. So we have B1 dash power alpha 1 and so on BK dash power alpha k. And then peli side le jao again. We are using what we are using here, B1 dash power beta 1, BK dash power beta k. What we are using here? G dash is they are elements of G dash. Phi આપી દે so this is phi of nothing but phi of G. Right? So એક વધારે step લખવું હોય તો phi of A1 power alpha 1 and AK power alpha k. And here we can write this is nothing but phi of A1 power beta 1, AK power beta k. This is how phi is defined. Right? So this is nothing but phi of G, phi of H. So phi is homomorphism. What will you show next? Phi is 1, 1. How do we show phi is 1, 1? Let us take phi of G equals to phi of H. So this implies phi of A1 power alpha 1 and AK power alpha k equals to phi of A1 power beta 1. Very easy, right? AK power beta k are both simple. So what is this? So this is B1 dash power alpha 1, BK dash power alpha k. and this is nothing but b1 dash power beta 1, b2 dash power beta 2, and then bk dash power beta k. Okay, next, what is next? Yes, Prabhat.
સર ઇન્ટરનલ ડાયરેક્ટ પ્રોડક્ટ યુનિક થશે ને?
Yes, so
Yeah.
this means that bi dash power alpha I is same as bi dash power beta I for all I equals to 1 to up to k. The reason is since G dash is direct product. It is direct product. External cube, internal cube, they are isomorphic. So it is direct product of B1 dash, B2 dash, and up to BK dash. So this is because of this direct product. So they are same, each of the corresponding, because this is in capital B1 dash. This is also in capital B1 dash. So they have unique expression here, right? This is also we had discussed. So unique expression. Unique expression. So that means this must be equal. And if suppose this is equal, then b1 dash bi dash power alpha for all I, they are equal. How do we show that alpha I equals to this? So what does this give us? So from this, see, this is same. So that means the power must be same. So therefore, alpha I equals to beta I for all I. And if alpha I equals to beta I for all I, then I can say that ai power alpha I equals to ai power beta I for all I. And if that is there, then the product a1 power alpha 1 up to ak power alpha k, this will be nothing but a1 power beta 1 up to ak power beta k, and this implies that this is nothing but this is g, and this is nothing but this is h. Clear? So this is 1 1, and phi is on 2 finally. So for on 2, what you will do? For on 2, we need an element here. On 2 is easy, right? Very trivial. Just from definition it follows. So एक element आमाथी लઈએ, if you take an element of g dash, what it will look like? So g dash is this. So that an element of g dash will look like some power of b1 dash, some power of b2 dash, and to some power of bk dash, like this. So as soon as we have powers, so we have alpha 1, alpha 2, alpha k. જેવા powers મળે, so we get an element. કયો મળશે element? a1 power this, a2 power this. So as soon as we get powers, raise it to ai power alpha I, and then apply phi. So it's done. Is it clear, or should I write? Let me write. Okay, so let say y belongs to g dash. Then y equals to b1 dash power alpha 1, b2 dash power alpha 2, bk dash power alpha k for some powers. So then take x equals to a1 power alpha 1 and ak power alpha k. So this will be an element of g, because they are just powers of a1, a2, ak. So this is nothing but it's an element of a1 cross cross ak. It's an element of g. Not only that, and if you apply phi on this, what is phi of x? Phi of x is phi of a1 power alpha 1, ak power alpha k, and this is equals to b1 dash power alpha 1, a1 ની જગ્યાએ શું આવશે? b1 dash, a2 ની જગ્યાએ b2 dash power alpha 2, and bk dash power alpha k, which is nothing but y, and this is in g dash. So this is y. So hence phi is on 2. Thus phi is on 2, and hence phi is an isomorphism. It's an onto isomorphism. Whenever it is an onto isomorphism, we say that or we say that G is isomorphic to G dash. Is it clear? So this is one of the most important result of the two groups, abelian groups of order p power n, if they have the same invariance. So let us take invariance. So suppose this has k invariance, suppose this has h invariance, and so this is a1, a2, ak. This is b1, b2, bs, and these are each cyclic group. And because here it's dash, we denote it by bi dash. And so this is p power ni. For this is this p power hj, pj dash. So now invariants are same. That means this number is same. K and f is same. And not only that, each of these integers n equals to h1, n2 equals to h2, they are also same. So all these are same. So then direct product we can write like this. So now the number is same, we know that. Also we know that each individual cyclic groups have the same power p power ni, p power ni for ai and bi dash both. So it's natural to define a map from G to G dash by, so what is an element of G looks like? Element of G looks like this. It's an element of first element coming from here, second element product of elements coming from A1, A2, AK. But if it is coming from A1, then it is some power of small a1. So let us call it a power alpha 1 for some alpha 1. If it's an element of A2, it is some power of A2. So let us call it a2 power alpha 2, right? So on, and it is some element of AK. It is some power of, because it's cyclic, so it is some power of small ak. So let us call it AK power alpha k. And once we have this, naturally here also it is the same. We use the same power. So this is how we define the map, b1 dash, b2 dash, and so on. And then just show that it is homomorphism. Yes, G is abelian, so all this will commit. So first take the product here, gather the powers, a1 power alpha 1 plus beta 1. So take it alpha 1 plus beta 1 here, collect all those powers of a1, then a2, and so then this is nothing but a1 power something, a2 power something, ak power something. So by the definition of phi, a1 power something, so that becomes b1 dash power the same power, and so on. So apply the map and then separate it out. That also can be separated because G dash is also abelian. Both G and G dash are abelian. So this you can replace in my notes. I have written use that result, but yesterday I realized they are that G is abelian. So we don't need to worry about all those things, that is inter-direct product. Just separate it as we want. So this collect all this bi and b1 dash power this. So this phi of G, phi of H. Similarly, 1, 1. Here we use the fact that the representation is unique. So first element is coming from b1 dash, and this also is coming from b1 dash. So they must be same. Similarly, for each I, these elements are same. But because these are same, the powers must be same. And therefore, we have alpha equals to beta I. But if alpha equals to beta I, ai power alpha is same as ai power beta I. And therefore, this product is same as this product. So that means nothing but G equals to H. It's 1, 1, and on 2 is clear from the definition. So phi is homomorphism, isomorphism, on 2 isomorphism. Therefore, G and G dash are isomorphic. And the converse part. So this one, we leave it right now. So if assume that this demands some work, G and G dash are isomorphic. Okay, now we have to show that invariants are same. So now we are in general case, this case. These are K in number, these are S in number. What we have to prove? We have to prove that K equals to S, the numbers are same. And not only that, we have to prove that Ni equals to Hi. So this is what we have to prove. So that demands some 2 lemmas and then the remaining part of the theorem. But let us postpone it. So right now, if we want to do, we'll do it then. Okay, so suppose we have proved this result. આના માટે લેમાસ ની જરૂર પડશે. But why did I choose this method? Because I don't want to go in the traditional that method, lemma, then theorem. એવું નથી કરવું. So this is the target what we were asking. અને હીરાલાલ કાલે જે પૂછતા હતા ને કે what happens about the groups, number of abelian groups. So this is the final result. The number of non-isomorphic and even if you forget after if you want to be in mathematics, if you forget the proof, but this statement you should remember the number of non-isomorphic abelian groups of order p raised to n is the partition of is equals to the partition of n. And now the proof must be simple, right? So if every group can be written as a product of G equals to, I'm not just writing exact proof, it is given in the book, I'm just explaining. So if G is this and AI is cyclic of this of order p raised to ni, then what is n? N equals to n1 plus the same remark which we have written, nk, where n1 is greater than equals to n2 greater than equals to nk. So this gives a partition. So that means if you have a cyclic group of order p power n, if you have an abelian group of order p power n, it can be written as direct product of cyclic groups of order p power ni, and that gives a partition. This is the same remark that we have written earlier. Conversely, suppose partition is given. Suppose n equals to n1 plus n2 and so on. Nk is a partition of n. Then we can find a group. Then we can find a group G S. Let A1 AI be cyclic group of order p power n. Create કરી શકીએ. ધારો કે આપણને partition આપેલું છે. Suppose we are given let us say 3 square. So we have to consider a partition of 2. Suppose partition is given 1 plus 1. We can always find. So we can always find 3 power 1 Z3. And we can always find another group of 3 power 1, which is Z3. So let's take Z3 cross Z3. So 3 power 1, 3 power 1. So what is this? So this is order of G. So G is a group of order 9. So conversely also 3 square. So that is conversely also we can do this. That suppose partition is given. So what we have to find? Find a group of order p raised to n1. You can find Malay cyclic group. Malay. That is nothing but Z p power n1. Then second one is given. Find a group of order p power. Find a group of order yes p power n2. Five multi cyclic group. Malay. Z p power n2. And so on. So take Z p power nk. We know cyclic groups are there. And then what? Take this direct product and call it G. Thank you. What is the order of G? N1 plus N2 plus Nk, which is nothing but order of G is nothing but p power n because sum is n. And what are the invariants of G? Same thing. So conversely, if partition is given, we can find the invariants also. Such a group whose invariants are exactly same. And take G equals to A1 cross AK. Then invariants of G are same as the partition. Then invariants of G are same as partition, given partition of n. right? Invariants of G are same as given partition of N. Okay, so and also by above theorem, because two groups, if they have the same partition, that means they are isomorphic. So we are not going to get different groups. So also by above theorem, two groups having the same invariants, that is same partition. Invariants gives us partition, are isomorphic. So that means if we have two groups, if they are isomorphic, we are not going to get any different partition, any different invariants. They are going to isomorphic. Yes. And if we take two groups, if they are not isomorphic, then it gives different partitions. So how many different non-isomorphic groups will be there? Hence the number of non-isomorphic groups. Hence the number of non-isomorphic groups. Abelian groups. But the story is here abelian groups. Abelian groups of order p power n is equal to the number of partitions of n. Okay. See this. The story is this. Don't see the length. See what I have written. કેટલા groups મળશે? 2 power 4 order na. So let us consider example. We'll understand. Order of G equals to 2 power 4. How many groups we will get? That is nothing but partition of. Let us take 2 cube right now. Nano number. Let us take 2 cube. 8. 8 order na 8 order na abelian groups. And G is abelian. How many abelian groups? Different means non-isomorphic abelian groups of order 8 are there. That depends on the partition of this. The partition of 3. So that is 3. Then we have 2 plus 1. Then we have 1 plus 1 plus 1. So corresponding to this, what we get? Z3 cube. Not Z2 cube. The prime is 2. And which is nothing but it is Z8. Corresponding to this, so also cyclic group. See p power n. And અહીંયા partition શું લીધું છે? What is this? Is n1. What is this? This is n2. Right? n1, n2. So p power n1. So z2 square cross p power n2. P to same h, prime is 2. So this is the powers we are taking, right? This is n1. Are you following? This is nothing but this is n1. And what is this? This is n2. Right? P power n1, n2. And so what is this? This is nothing but z4 cross z2. Or we can take this is same as z2 cross z4. What about this? 2 cube. 2 cube, but what is it? Has three invariants. 1, 1, 1. There are 3 invariants. So what is the zp power n1? N1 is 1. Zp power n2. N2 is 1 cross zp power n3. Cyclic group. So this is nothing but it is z2 cross z2 cross z2. And all are this distinct. You can see every element here has order 2. There is no element of order 4. There is no element of order 8. Here there is an element of order 4. But there is no element of order 8. And બધા element જોશો ને તો બધા 4 order. Here there is an element of order 8. That means they are all non-isomorphic. How many are there? How many abelian groups of order 3, order 8 are there? Non-isomorphic, there are 3. One is this. This is the first one. This is second. And this is third. There are only 3 because partitions of 3 are 3. Right? Another example. So how many groups of order G, again abelian, and let us consider 3 cube, 27. How many will be there? Can anybody tell? You ask it, so this is important. Understand this. How many groups will be there of order 27 abelian groups? कोई नहीं? हाँ. So again, yes, Mitiksha.
3.
3.
Partition
It
of
depends
3.
on this 3 or this 3.
2.
Yes, it depends
Power
on
value
this
3.
partition of 3. Yes, so again the same partition. So 3 is, we can write 3, and then we can write 2 plus 1. And also 1 plus 1 we can write. So 1 plus 2 we can write. And then 1 plus 1 plus 1. So this is how we write. Right? So corresponding to 3, this is ZP power n. So this is P power n, which is nothing but 3 cube. So for us, as I said, P is not important. What is important is n is important. Partition of n. What is n? N is 3. So ZP power, and how do we write this? We write this as P power n1 વાળું એક group મળશે. પછી બીજું આવશે P power n2 વાળું, and then we have P power nk. Right? We have subgroups like this. So P power n1. What is n1 here? There is only n1, only એક જ છે. So this is 3 cube, which is nothing but this is Z27. What about this? So this is ZP power n1. So this is, what is n1 here? So P is 3. P is 3, n1 is 1. So 3 power 1, and then 3 n2. What is n2? Or 2 n1. This also we can write 2 n1, because n1 is larger we write. So it's better we write like this, 2 plus 1. So 2 is n1, and then n2. So this is nothing but Z9 cross Z3. You can see any other 9 order no element here, but there is no element of order 27. This is cyclic. There is an element of order 27. And the third one you get is Z3 cross Z3 cross Z3. I hope this is clear. Do you want to take another example? Try this. Order of G is all abelian, huh? And order of G is, let us take 16. 16 plus also 2 power 4. How many non-isomorphic abelian groups will be there? Yes, Prabhat.
5.
5, that is nothing but partition of 4.
Right.
So partition જેટલા 4 ના partition મળે ને. Yes, so even if I take 16 or if I take 81, this is fine. 81 પણ શું છે? Or I can take order of G equals to 81 also, because that is also 3 power 4. So it depends on this. It does not depend on the prime. I'm again saying it does not depend on the prime. It depends on this. So 4 na partition, there are 5 different partitions of 4. We can write as 3 plus 1. We can write this as 2 plus 2. We can write this as 2 plus 1 plus 1. And then finally 1 plus 1 plus 1 plus 1. Right? So corresponding to this, what is the group? There is only one, P power n1. What is P here? This is 2 power this 4. So that will be nothing but Z16. Z16. What will be here? We have Z2 power, prime is 2, so prime will be here. Prime no role is here. 2 power 3 cross Z2 power 1. So that is nothing but Z8 cross Z2 and so on. So if I take 81 what to શું થાય? If I have taken this, so here we would have, or here we would have, instead of Z16, we have 3 power 4. Right? Z3 power 4, that is nothing but Z81. Z81. So here if we can either have Z, whatever, it depends whether if we are taking 81 or not. So we have Z3 cross Z3 cross and 4 times. So Z3 cross Z3. Or if we take 2 powers of 2, 2 power 4, if we want 16. So we have, for this partition, the same partition, we have Z2, 2 power 1 cross Z2 power 1 cross Z2 power 1 cross Z2 power 1. Okay, so if I say that invariant is 4, that means the group is always cyclic. If I say that invariance is 3, 1, the group is not cyclic. If I say this, the group is not cyclic. If I say this, the group is not cyclic. Cyclic ક્યારે થશે? એક જ હોય ત્યારે. પોતે cyclic group, it is same. The invariant is only 1. That is the highest power. That is n. N1 is itself n. That there are no n2, n1. And as a corollary, finally, what if they are given in product? A group of order, every abelian group. So number of non-isomorphic group of order, number of non-isomorphic groups, isomorphic abelian groups of order e power same. Let us use the same notation as used in notes. Yeah, p1 power alpha 1. Suppose the group is given like this: p2 power alpha 2 and pn power alpha n is nothing but p of alpha 1. This p is partition. P of alpha 2 and p of alpha n. Right? Again, let us consider example. How many will be there? Of course, it is natural that it will be product. So G is, suppose G is abelian, and let us say order of G is, let us take 72 લીધું હતું, 8 into 9, right? So 8 into 9, and what is 8? So that is 2 cube, and 9, that is 3 square. So how many groups of order 8 are there? That depends on the partition of this. So આના કેટલા આવે? તો કે આના 3 આવશે. So let us call it A1, A2, A3. આના કેટલા આવે? તો કે આના 2 આવશે. Partition of 2, yes, partition of 2 is 2. So let us take it B1 and B2. So how many combinations do we get? So we get so many combinations: A1, A1 B1, A2 B2, sorry, A1 B1, A1 B2, A2 B1, A2 B2, A3 B1, A3 B2. કેટલા combinations here? Total 3 into 2, which is 6. The 3 is nothing but it is partition of 3, and this is partition of 2, so which is 6. Is it clear? 3 na partitions, 3 meda. So this has 3 and this has 2. So how many combinations we can have? So that is a product, and that is why here we have the product. So what are the groups? So the groups are like this. So partitions of 3 I can write as 3 and 3, 2 plus 1, and then 1 plus 1 plus 1. So this is corresponding to 2 cube. So this 3 I am writing here, right? And now this is corresponding to 3 square. Don't get wrong. This is the 2 I am writing, 2 here and 1 plus 1 here. So the groups will be, here the prime is this. Here this is the prime, and here this is the prime 3. So the groups will be, what will be the group of order 72? So the groups will be like this. So Z, I am taking here the first power. So this is 2 cube cross Z 3 square. That is 1. What partition I am taking? 3, here 3, and I am taking here and 2. And then the second one will be Z, I am taking 2 raised to 1 cross Z this, and cross Z3 square. So here the partition is 2 only, the same. સમજાય છે ને તમને? અહીંયા 2 જ રાખ્યું છે. But here I am changing. Instead of this 3, I have written as 2 and 1. Right? So this is like this. And then the third one also Z2 cross Z2 cross Z2. That takes care of this. અને અહીંયા હજી 2 જ રાખવું છે. So this is Z3 square. Okay, so this corresponding partition is 2 plus 1 અને અહીંયા 2 જ. કેટલા combination બને? 3 અને 2, then 2 plus 1 અને 2, then 1 plus 1 plus 1 and 2. So 3 એ થયા. And then again 3 and 1 plus 1, 2 plus 1 and 1 plus 1, 1 plus 1 and 1 plus 1. So there are 6 combinations. So this is the again 2 cube, but this time I am not taking here 2. This time I am taking, so this is what partition? 1 1. આ 2 નું કામ કરે છે. Here the prime is 2. Here the prime is 3. But the power of 3 is 2, so the partition is of 2. And so here this is 2 only. And now going further, so this is now I'm not using anu partition ફરી પાછું આ જ આવશે 3. Let me take 2 plus 1 and again 1 plus 1 plus 1. પણ હવે અહીંયા શું આવશે? 1 plus 1, 1 plus 1 and 1 plus 1. So this is 3 power 1, 3 power 1. ઉપર કરેલું હતું એ જ, પણ now we are combining both of them together, right? And what about this? Okay, Z2 power 2, Z2 power 1 and Z3 power 1, Z3 power 1. And what about this? Okay, Z2 power 1 cross Z2 power 1 cross Z2 power 1. Now I am taking the invariance 1 1 1, and here also I am taking the invariance 1. So again Z3 power 1, Z3 power 1. So how these are the 6 groups, all have order 72, but they are non-isomorphic. The first one will be Z8 cross Z9, right, which is nothing but it will be Z72. Don't go into this right now, but consider this. The second one will be Z4 cross Z2. Right? I have taken 2 and પછી 1 break કરી દીધું અને અહીંયા Z9 as it is. Z9 આ ત્રણેયમાં સેમ જ રાખીએ છીએ Z9, but here we have changed Z2 cross Z2 cross Z2 and Z9. And now here we are not considering Z9. Here we are considering Z3 cross Z3 in all of these 3. Z3 cross Z3. And here also Z3 cross Z3. So I'm considering this partition 1 plus 1. So Z3 power 1 and Z3 power 1. But here again first one is Z8. So Z8 cross Z3 cross Z3. Then what about this? Now not 8 but 4 and 2. Right? So then this is just like this second case. Z4 cross Z2. And the third one, take all this is Z2 cross Z2 cross Z2 and Z3. So these are all the groups. So I hope this is clear. You can try some examples which are given in exercise of my notes. And what remains is this, the converse of this. Two groups are isomorphic if and only if of P power n, if and only if they have the same invariance. And આના માટે થોડું process કરવી પડશે, but I think just a minute. Yeah, so we need to consider some lemmas for that, right? And that we will maybe see on Monday.